Alright, so today we're going to be, talking about space with some amazing gameplay to get your attention. Well, but anyways, welcome to Space Explained by a 10-year-old. So, space is just apparently something very big and very empty. Very, very empty. How empty? Very empty. But anyways, so let's take black holes for example. Those dog vacuums, they just clean up things. They are trying to be bigger to make their parents proud. Kind of like a child getting good grades. But anyways, kind of like a child getting good grades. But anyways, let's talk about pulsars now. Pulsars, yeah, they are just spinning things. But you want to know how fast they spin? Very fast. They spin 11 times a second. The fastest one was spin over 700 times a minute. And yeah. And stars, these are just some burning things. They burn hydrogen, but if they run out of hydrogen, they burn helium, which makes the red giant, which will what happen to our sun in the future. Very, very far future. How far we're talking? 5 billion years. That's how far we're talking in the future. And yeah. Now let's talk about some planets. Dwarf planets like Pluto and Mercury, yeah, they're just womp womp. Yeah, they failed to become an actual planet. Well, Mercury is a planet, but not like a real planet. Not like what I mean is that it's just bigger than Pluto, but smaller than all of the other planets. And we got and take Jupiter for example. Jupiter is a big guy. How big we're talking about? 139 kilometers. Yeah. Very big indeed. But half of our solar system has rings. Like half of the planets in our solar system have rings. Yeah. But we got Saturn. Take Saturn for an example. It has big rings, bigger than all of the solar system's rings. But Saturn's rings will womp womp. And what I mean by womp womp is it will go bye-bye, which means they will be gone. Yeah. And also, let's talk about some quasars. I don't know anything about them, but all I know is that they are just spinning. They are just spinning black holes. With emitting so many energy. It could be enough energy to charge your iPhone for so fast. Yeah, it has enough energy to charge your iPhone too fast. And we got supermassive black holes now. They're kind of just like the same as the black hole topic, but they're big boys. But I just realized how big our galaxy is because supermassive black holes are usually in the center of galaxies. But when I see the real scale, I just imagined what does the galaxy look like compared to a human? And boy, do I have to tell you, really big. How big we're talking? Even bigger. even bigger than everything in the Milky Way. And we have our neighbor Andromeda, which might collide with the Milky Way at the same time as the sun will boom boom. And yeah, the sun might boom boom, and Andromeda might collide with the Milky Way. It's like a, you know, it's like merging. And that was like a picture. It was like a cluster of galaxies. But some people, including me, found a question mark. Like it looks like some sort of index. But this index is not, completed yet. It's like a Pokemon index. There's so many like Pokemons. I don't get it how people know a lot of them. And the shiny ones. Okay, we're not going to talk about Pokemon no more. We're talking about space. That's what I was supposed to talk about. Anyways, wait. What topic should I say next? Nebulas, yeah. Nebulas are often formed when a supernova happens in a different way. Like, nebulas are formed when a supernova happens in a different way. Yeah, and the coldest one yet is the Boomerang Nebula. Because almost all of its atoms are almost stationary and motionless. Which is very close to absolute zero. It's just the same amount as my brain cells. And yeah, that could be it. So yeah. Like and subscribe, please.